Good morning, dear students. St. Joseph's College for Women Autonomous, Vishakhapatnam. Welcome to St. Joseph's open web-based learning platform. So, e-learn for a soulful and enriching e-learning experience. Department of Chemistry presents MOOC, St. Joseph's massive open online course, Pharmaceutical and Medicinal Chemistry, a modular skill elective course. I am Dr. L. Chinnari, lecturer in chemistry, St. Joseph's College for Women Autonomous, Vishakhapatnam. Pharmaceutical and medicinal chemistry. Module 3 is chemotherapeutic drugs. Chapter 3.2 is sulfur drugs. By the end of this chapter, learner would be able to summarize the characteristics and effects of antibiotics, depict the structure and synthesis of sulfanilamide, comprehend its pharmacokinetics and pharmacodynamics, understand the applications and adverse effects of sulfonamide. So these are the contents of this chapter: introduction, definition, structure, application, synthesis, indications, pharmacokinetics, pharmacodynamics, and adverse effects. Introduction to antibiotics. So we discussed already in the last video what are the antibiotics. So antibiotic drugs have antibacterial effect also. They are also called antibacterials. The word antibiotic means against life. Literally, any medicine that destroys germs in your body is an antibiotic. Antibiotics help to stop bacteria caused infections. They act either by destroying the bacteria or preventing them from cloning themselves or reproducing. Some antibiotic classes work by killing bacteria and other work by preventing the ability of bacteria to multiply. So, coming to the classification of antibiotics, so this classification is based on the chemical structure of the antibiotic. Based on the chemical structure, antibiotic classes are aminoglycosides, cephalosporins, tetracyclines, penicillins, sulfonamides, also called sulfur drugs, fluoroquinolins, macrolides, carbapenems, lincosamides, glycopeptides. So, coming to the desirable characteristics of antibiotics, first one is it must be effective against a pathogen. Second one is it must not produce significant toxic side effects. Third one is it should be sufficiently stable so that it can be isolated and stored in a suitable form of dosages which are readily absorbed. Fourth one is the antibiotic should be completely eliminated from the system soon after its administration has stopped. Antibiotics are usually classified based on their chemical structure, and sulfur drugs are a class of antibiotics that contain sulfur in their structure. So, this is the example for natural product containing sulfur. Variety of sulfur containing scaffolds widely exist in natural products and drugs. For instance, epidithiodiketopiperazine is also called ATP, characterized by sulfur atoms, and diketopiperazine structure comprises a large number of metabolites which display a range of biological activities including antiviral, antibacterial, anti-allergic, anti-malarial, and cytotoxic properties. Coming to the definition for sulfur drugs, sulfur containing compounds often show different biological activities and serve important functions. So, they find applications in the pharmaceutical industry. Sulfonamides are a group of man made, that means synthetic medicines, that contain the sulfonamide chemical group. These are called sulfur drugs. So, these are the examples for sulfur drugs. So this is the first one. First example, its chemical structure is sulfanilamide. So it is sulfur diazine. This is sulfur pyridine. This is sulfur salagine. So these are the chemical structures for sulfur drugs, and these are the examples for sulfur drugs. In this chapter, sulfonamides will be discussed among all the sulfur drugs. So this is the example for sulfonamide. Sulfonamide drug were the first antimicrobial drug and paved the way for the antibiotic resolution in medicine. The first sulfonamide was trade name Prontocin, which is a prodrug. Gerhard Domack received Nobel Prize in Medicine in 1939 for discovery of sulfonamide. So coming to the structure of sulfonamide, this is the sulfonamide. Its IUPAC name is 4-aminobenzene sulfonamide. Its molecular formula is C6H8N2O2S. So the C6 indicates 6 carbons in the benzene ring. This 8 hydrogens indicates 4 hydrogens from this NH2 group, 2 NH2 groups, and rest of the 4 hydrogens indicates from benzene ring. And N2 indicates presence of 2 amine groups. So O2 indicates these two oxygens attached to sulfur, and one sulfur indicates this sulfur. So finally C6H8N2O2S is the molecular formula of sulfonamide. So its molecular weight is 172.21 gram per mole. Its properties is sulfanilamide is a white crystalline powder. Its melting point is 170 to 173 degrees Celsius. It is soluble in water. So coming to the synthesis of sulfonamide. So this is the general synthesis of sulfonamides. So in this synthesis, benzene is a starting material. In the first step, benzene reacts with mixture of sulfuric acid and nitric acid. It's converted into nitrobenzene. So we know that nitric acid, a mixture of nitric acid and sulfuric acid is used to introduce the nitro group on a benzene. It's also called nitration. So in the first step, benzene converted into nitrobenzene. Nitration reaction will be occurs in the first step. So in the second step, nitrobenzene reduced to aniline. That means nitro group reduced to NH2 group in the presence of a reducing reagent, tin and HCl. So we know that addition of oxygens is called oxidation. Addition of hydrogens is called reduction. So in this reaction, addition of hydrogens will be occurs. That means reduction will be occurs in the presence of a reducing reagent tin. So in the third step, this aniline reacts with acetic anhydride. It gives acetanilide. Acetanilide. In this reaction, acetylation will be occurs. That is also an acetylation because this NH2 group reacts with this acetic anhydride and it forms acetanilide. So in this nitrogen having lone pair of electrons, that lone pair of electrons attacks the carbonyl group. The sigma bond between the oxygen and carbon shifted to oxygen. It gets O minus and this COCH3 attached to this nitrogen, and rest of the COCH3 and O minus gets hydrogen from this NH2 because after addition of COCH3 it gets positive charge because it's having 4 bondings. Then it abstract this CH3COO minus abstracts that hydrogen, so it's converted into CH3COO minus. CH3COO minus H. It gets H and acetic acid. CH3COO H acetic acid. So aniline reacts with acetic anhydride. It gives acetanilide with a byproduct acetic acid. This and the next step, acetanilide reacts with sulfonyl chloride. It gives 4-acetamidobenzene sulfonyl chloride. So we know that NH2 NR2 or NHR is a electron donating group. So electron donating group activates the ortho and para positions. So electrophile attacks at ortho position or para position. So here electrophilic substitution will be occurs. Compared to ortho position, at para position, major yield will be formed because the presence of steric hindrance between ortho and this substituent, electron donating group substituent. So in this step, acetanilide finally gives 4-estamidobenzene sulfonyl chloride. In the next step, 4-estamidobenzene sulfonyl chloride reacts with amine, that means ammonia. It's converted into sulfonamide, 4-estamidobenzene sulfonamide. So finally on hydrolysis it gives sulfonamide, 4-amino benzene sulfonamide. So this is the synthesis of sulfonamide. So I am summarizing this synthesis. Benzene is acting as a starting material. It reacts with nitric acid and sulfuric acid mixture. It's converted into nitrobenzene. In the first step, nitration will be occurs. This nitrobenzene reacts with a reducing reagent tin and HCl. This nitrobenzene converted into aniline. It is in the second step, reduction will be occurs. In the third step, this aniline reacts with acetic anhydride. It's converted into acetanilide. So in this step, N-acetylation will be occurs. In the next step, acetanilide reacts with sulfonyl chloride. It gives 4-estomidobenzene sulfonyl chloride. So in this step, electrophilic substitution will be occurs at a para position as a major product. In the next step, this 4-estomidobenzene sulfonyl chloride reacts with ammonia and it gives 4-estomidobenzene sulfonamide. So finally, on hydrolysis, it gives 4-amino benzene sulfonamide. So this is the synthesis of sulfonamide. Coming to the applications and indications, it is used for diseases like uh, sinusitis, tonsillitis, bronchitis, gonorrhea, pneumonia, pus in air, eye, conjunctivitis, etc. Indications. Sulfur drugs are bacteriostatic drugs, mainly acts against gram-positive bacteria and a few gram-negative bacteria. It is mild in action when compared to present-day antibiotics. In combination with trimethoprim, the efficiency increases and become bactericidal in action. This is called synergic effect. So coming to the pharmacokinetics and pharmacodynamics, pharmacokinetics, sulfonamides are well absorbed from the small intestine. After absorption, they are distributed to all the parts of the body. They undergo acylation and oxidation in the body. It is metabolism. It is excreted from kidneys. So coming to the pharmacodynamics, para-aminobenzoic acid is essential for the growth and multiplication of microorganisms. The structure of para-aminobenzoic acid is similar to the structure of sulfonamides because the structural similarity. The microorganisms taken up sulfonamides instead of para-aminobenzoic acid by mistake, and this inhibits the growth and multiplications of microorganisms, and this type of drug action is called metabolite antagonism. So this is the structure of sulfonamide, this is the structure of para-aminobenzoic acid. So we can observe clearly structural similarity of sulfonamide and para-aminobenzoic acid. So coming to the contraindications, adverse effects are crystalluria and kidney stones. Most of the effective sulfonamides are less soluble in water and hence they form crystalline aggregates in the kidney. This leads to crystalluria and stone formation. Hence, patients using this drug should consume water liberally. Use of the drug decreases the erythrocytes and hemoglobin contents in the blood, thus consume thus causing hemocytic anemia. Pregnant women should not use the drug as it produces toxic effects in the brain of the fetus. Nursing mothers should not use the drug as it affects lactation. So, finally, sulfur drugs. In a nutshell, we have learned the meaning of the word antibiotic along with its important characteristics, definition, structure, and properties of sulfur drugs, and that they contain sulfonamide functional group, mechanistic pathway for the synthesis of sulfonamide, the pharmacokinetics and pharmacodynamics of sulfonamide containing drugs, along the applications, indications, and contraindications of sulfur drugs. Thank you.